Hello, this video presents the techniques for application of an acrylic pin external fixator. An acrylic pin external fixator is an external fixator in which the metallic connecting clamps and connecting bars have been replaced with acrylic columns. This simplifies device application and increases the surgeon's efficiency. All the materials necessary for creation of these fixators are now available in a convenient, economical kit known as the APEF system. Acrylic pin external fixators were first described for use in the treatment of human tibial fractures in the 1960s. Their lightweight, ease of application, and versatility quickly led to their use in various veterinary applications. However, one problem periodically noticed was that of fracture of the connecting bar and loosening between the acrylic connecting bar and the fixation pins. This led us to perform research which compared the standard medium Kirschner apparatus against 3 diameter acrylic external fixators. While the results of the study varied depending on the diameter and configuration of the fixator, we did find that with a 22 millimeter diameter acrylic column, the APEF system was significantly stronger than the comparable stainless steel frame in axial, torsional, anterior-posterior bending, and medial-lateral bending. Likewise, the stiffness of the 21 millimeter APEF system was similar or significantly greater than the corresponding Kirschner stainless steel frame in all 4 modalities tested. The standard size fixator is useful on dogs and other animals weighing more than 10 to 15 kilograms. The mini-sized fixator is used primarily on cats and small dogs with interesting application potential on birds and other exotics. The APEF base kit is provided by Innovative Animal Products in the component storage container. And within this container, as pointed out, are the fixation pins and the acrylic packs necessary for creation of several of our acrylic fixators. The first thing that we'll find in our kit is a sterilizable pin tray, and it contains the fixation pins that we'll be using. 4 pins are provided in the kit, and first off we have an end-threaded medium-sized 1/8 inch diameter pin. This is useful for type 1 configurations. Second, we have a centrally threaded medium-sized 1/8 inch pin. Both these threaded pins provide enhanced bone holding capacity. The third pin is a non-threaded medium-sized or 1/8 inch pin, and it's useful because of its economy and strength. The last pin provided is the 3/32 or smaller size pin. This is useful in the creation of the mini fixators. Also, the sterilizable pin tray is a good place to be storing the clamps and bars that we'll use as a temporary alignment guide. Here we're demonstrating the specially designed and made temporary alignment frame that we'll be illustrating later in the tape. It's also a good place to store Kirschner device components. Also, in the base of the container, we'll find our acrylic tube packs. These are provided in 3 sizes: a 1/2 acrylic tube pack, a single acrylic tube pack, and a double acrylic tube pack. These are provided either pre-sterilized or non-sterilized, which means that the contents of this package, the outside of those contents, are sterilized. Within each one of these packs, we'll find our prepackaged acrylic mixing pack and the tubing with the associated stopper for creating our acrylic column. The 1/2 acrylic pack contains 1 ounce of acrylic, which is enough to fill one of the mini tubes. The single acrylic pack contains 2 ounces of acrylic, which is enough to fill either 2 of the mini tubes or 1 of the standard 21 millimeter tubes. And the double acrylic pack contains 4 ounces of acrylic, which is enough to fill 2 of the larger tubes. Also, the single and double acrylic packs contain a connector which is useful for connecting the molding tubes to create longer acrylic columns. This video demonstrates the application of the acrylic pin external fixator to a radial and ulnar fracture model. We've suspended the limb from the ceiling by the paw as we would in a real clinical situation. For the most distal pin, we are pre-drilling with a drill bit approximately 90% of the diameter of the final pin. This is a positive profile or enhanced threaded pin which will provide increased longevity of fixation. The pin is inserted slowly so as not to cause thermal necrosis. We're now going to our second pin, this on the proximal fragment. It being a positive profile threaded pin is likewise pre-drilled and then the pin slowly inserted. The third and fourth pins in our medial plane are now inserted, and the cranial aspect of this biplanar configuration is now being constructed. These intermediate pins are non-threaded, so they can be directly placed by low-speed insertion, whereas this most distal cranial pin is again a threaded pin and is pre-drilled. Notice how the pins can be in any alignment as to best fit the fracture in the anatomy of the region. To facilitate placement of the molding tubes, it is sometimes useful to bend a few of the fixation pins so that they will be in alignment with each other where the tube is placed. Notice, however, we protect the bone pin interface from forces as we bend these pins into alignment. Now we're getting the acrylic material out. Comes in this package system containing both the acrylic and the pre-sterilized tubes. The molding tubes are inserted over the ends of the pins and slid down the lengths of the pin until they are positioned approximately a finger or thumb's distance away from the skin. Finalizing our first tube placement, and now we're applying the second tube, inserting it over the pins and likewise adjusting its placement away from the body. For this biphasic application, we now use a temporary alignment or reduction jig. In this case, we're illustrating using the Kirschner type apparatus as this temporary clamp. We slide 2 single connecting clamps on the ends of protruding fixation pins, adding a connecting bar, reduce the fracture, and tighten these temporary clamps in place. Now we're adding a second set of connecting clamps and a bar to 2 of the cranially oriented fixation pins while holding the fracture in reduction, either by close manipulation or observing the fracture openly, and tightening the clamps to hold the device in place. Now we're ready to mix our acrylic. As you can see, the acrylic is all contained in this single bag with the temporary divider. Pulling the ends of the bag apart, combine the liquid and the powder. We have 2.5 minutes from the time that this powder is mixed with the liquid to mix it up and form this nice viscid fluid. Here we're out at about 2 minutes. At this time, we start to roll one end of the package up, kind of like a tube of toothpaste. Now we're ready to cut off one corner of our mixing bag and pour the acrylic. You can see it's pouring down one of the tubes. If we have a little bit of leakage develop around one of the pinholes, a little bit of cotton pledget or ball can be used to control that leakage. Now we've poured both tubes full of acrylic. Notice we have a little bit of leakage, but there was plenty of acrylic to fill both tubes. As the acrylic starts to cure, the cotton balls can be removed. It takes a total of about 10 minutes for the acrylic to fully harden. At that time, the temporary alignment and reduction clamps, the Kirschner type device in this case, can be removed. The end of the protruding fixation pins are cut off using a large pin cutter. The last of our external fixator pins are removed, and any excess molding tube can be cut off. So this is the final appearance of our acrylic pin external fixator. Using the same fracture model and a new set of fixation pins that were inserted as previously described, we'd now like to demonstrate the use of a purpose-designed temporary alignment and reduction frame and clamp. These are different in that they're applied directly to the fixation pins and slid down to the level of the skin before the tubes are inserted on the ends of the pin. Here we're applying our clamps and connecting bar to 2 medial pins. We're going to manipulate the fracture into reduction either by closed manipulation or by open fracture exposure and reduction. Now we're placing our second set of clamps and connecting bar on the cranially oriented set of pins, again sliding these clamps down to the level of the skin, achieving reduction of our fracture and tightening these clamps for our temporary reduction while we apply our acrylic tubes. Next, we cut our fixation pins off with the large pin cutter, leaving just enough length so that the pin will extend into the center of the tube and be incorporated in the acrylic. Here we're popping our tubes on the ends of these pins, and notice now we only have to perforate the tubes on one side. It's much easier to place these tubes and pale them on the ends of the tube. It's the more medial tube that's being applied. Again, it's pushed down onto the connecting clamps. And here we're placing the cranially oriented tube. Now we're adding the caps to the ends of our tubes, pushing them in, making sure they're well secured. And here's our acrylic sealed in our mixing bag. By pulling the two ends of the bag apart, the temporary divider is popped off and we start the mixing process. We have 2.5 minutes of mixing. This material starts in a very liquid phase, as you can see here. At 2 minutes, we see how the acrylic is starting to become quite viscous. Again, we roll up the bag, kind of forces the acrylic all in one end of the bag, so we decrease wastage. Cutting off the corner, we now have our pouring device. And notice how it's a nice, smooth, velvety type appearance. Pours smoothly. That precludes bubble formation. We want to pour it up well above the top pin. Much less leakage with this application technique than with the form previously described, where we had holes in both sides of the tube. We have about 2 minutes with this particular type of acrylic to work with it longer than most commercial acrylic materials. We've had this specifically formulated so that it gives us a longer working life, and we can get it poured and where we want it before it becomes too viscous to pour. If we want to interconnect the two connecting columns, this can be done by taking extra pin stock and driving it through the acrylic before it's totally set. Then we cut off any protruding pin ends and force the tube around it. And what you'll notice here is we don't have any pin ends that will cause later problems. The acrylic takes a total of about 10 to 12 minutes to set. It is quite exothermic, but it doesn't create so much temperature as to go down the pin and burn the soft tissues. Once the acrylic is totally set, again 10 to 12 minutes from the time we started mixing, we go ahead and loosen our temporary alignment clamps and bars, remove them. Then we can cut off any excess molding tube that we didn't fill with acrylic. And remove our caps. And here we see the completed acrylic pin external fixator. We will use a clinical case to illustrate the typical decision-making process and radiographic progression when using the APEF system for fracture management. This is the tibia of a 6-year-old Springer Spaniel that sustained a distal open fracture when the dog was hit by a car. Notice the very short distal fragment, which would limit the fixation ability of devices applied in only one plane, and the comminution of the fracture, making it inherently unstable, which will require very rigid fixation for optimal fracture healing. The postoperative radiographs demonstrate the ease with which the fracture can be evaluated, since the acrylic sidebars minimally interfere with X-rays. The use of both threaded and non-threaded pins can be seen. Overall fracture alignment and reduction of the fracture are sought. Torsional alignment is evaluated by observing the projectional similarity of the joint above the fracture and the joint below the fracture site. In this case, both the reduction and alignment are excellent. Adequate reduction is usually considered to be at least 50% cortical contact in the worst of 2 perpendicular projections. If our postoperative radiographs were to demonstrate inadequate fracture reduction, the fixator can be adjusted. A cast cutter or saw is used to make 2 cuts and to remove a short segment of the acrylic column over the fracture. A similar length of tubing is removed from each end of the remaining column. A drill or burr is used to create holes in the periphery and the ends of the columns to serve as footings. A small additional amount of acrylic is mixed to dough consistency, usually requiring 4 to 5 minutes. This acrylic is then hand molded into the column defect and around the existing column ends to form a patch. The fracture is remanipulated into reduction and held until the acrylic patch cures and hardens. Radiographs taken 6 weeks after surgery demonstrate the APEF has remained stable. Mild periosteal proliferation is seen around several of the pins and should be correlated with clinical appearance of pin tracks. Early fracture healing is underway as noted by the loss of fracture fragment sharpness. If a very rigid frame configuration such as this type 3 was initially applied, staged disassembly or dynamization should be considered at this time in order to stimulate the hypertrophy and remodeling phase of healing. Removal of an acrylic sidebar can be performed with a pin cutter by cutting each pin between the skin and the acrylic column. The resultant type 1 or dynamized configuration is much more flexible, allowing weight-bearing forces to stress the fracture, stimulating hypertrophy and remodeling. Radiographs taken 12 weeks after fracture treatment demonstrate healing with a minimum of periosteal callus formation. This suggests primary healing with good fracture hypertrophy and remodeling. We generally feel the fracture is ready for fixator removal when cortical continuity is apparent in at least 3 of the 4 bony outlines in our 2 perpendicular views. Removal of the fixator can also be accomplished with a saw, either by cutting the pins or by cutting the acrylic sidebar itself. The remaining portion of smooth, non-threaded fixation pins can be removed with a hand chuck using a mild twisting pull. Threaded pins are removed using a hand chuck in an unscrewing motion. The remaining skin defects are not sutured but cleansed and will granulate closed within a few days. The acrylic pin external fixator is an easily applied, economical device. It provides excellent fracture stability, it is biologically friendly towards fracture healing, and it can be used on a wide variety of orthopedic problems. Consequently, I believe the APEF system will find wide application for fracture management in the practice setting.